Okay, this is part 2 of the quiz video. So this is the second question, and we're looking at 3 cars or toys that are connected together. And because they're connected together, the important thing here is they're going to have the same acceleration. They're connected as one object, and whatever force is being applied is going to be exerted throughout the object so that they're moving the exact same way. So we're going to treat these cars as a system. So we're going to have a system mass and a system force. So what we're going to do is, for the mass, we're going to add up the individual masses here to get an overall mass. We're going to call that M system, so 1250. And the force that's pulling all 3 of these objects is going to be 1500 newtons. So we're going to call that the system force, 1500 newtons. And from this, I can get my acceleration. So in this case, the acceleration is going to be the force over the mass, which is 1.2 meters per second squared. So I know that all of these objects are accelerating the same way, 1.2 meters per second squared forward. So next step is to draw a free body diagram of all of the vehicles here. So the first vehicle, what we know is the following. We know that it has a mass, a mass of 250 kilograms. I know it's going to be pulled by a tension force here. There's no friction, so there's no force behind here. And I know that the acceleration is 1.2 meters per second squared. Second object I know has a mass of 750 kilograms. And it's being pulled by a second tension force, which I called Ft2. And there's also a reaction force, Ft1, of the first vehicle pulling back this way. I also know the acceleration is 1.2 meters per second squared. The last vehicle I know has an acceleration of 1.2 meters per second squared. It has a mass of 250 kilograms. And it has 2 forces acting on it horizontally. The tension force from the previous vehicle and the applied force that was pulling all 3 of them together. Now for this question, we're going to be ignoring all the vertical forces. So gravity, normal, we're not going to calculate them. We're just going to assume that they cancel and that they're insignificant since there's no friction in this particular question. So now we've done this, what we want to do is we want to look at the sum of the forces acting on each object. So I always start on the easiest one, the last object. So in this one, the overall forces acting on this vehicle are just simply tension 1. I don't know what it is, but I know the mass of the vehicle and I know the acceleration of it, so I can figure out the overall force acting on it from second law equation. So I know that my second law equation is F net equals ma. So in this case, the acceleration of the first object times its mass gives you my overall force, and that's exactly what I substituted in here. So in this case, my tension force is 300 newtons. So because this is the tension force in this object, that's the only overall force acting on it. Now the second object, I'm going to draw another free body diagram, or sorry, keep track of the force, sum of the forces. So the sum of the forces here equal to the tension force 1 plus tension force 2. What do we know? I know Ft1, 300, but it's backwards, so put a negative in front of there. I also know the mass of this object, 750. And I know its acceleration, 1.2. So we multiply it through, and we end up with a value of 900 newtons is equal to negative 300 newtons plus Ft2. So now Ft2 is going to equal to 1200 newtons. When I bring the negative over, it becomes a positive. So the tension force here is 1200. And it makes sense it's larger because this force is pulling 2 objects. It's pulling the first vehicle plus the second vehicle. Now, the last free body diagram it's an extra one, and this is just more or less to just double check to make sure that everything is correctly done. So we want to figure out, in this case, we're going to determine our applied force. We're going to assume that we don't know what it is. So we're going to calculate the sum of the forces, which equal to the mass of this object times its acceleration. So here it's going to be 300. I know Ft2 from before is 1200 newtons backwards. And we're going to solve for the applied force. So when I bring the 1200 newtons over, it becomes 1500 newtons. That is my applied force. So what I've done is I've effectively checked my calculation to make sure it's correct. Next step is to add the numbers to the forces on the free body diagram. This is the same free body diagram. All we're going to do is we're going to add some forces. So we have our FT1 is positive 300. Here it's negative 300 newtons on this particular vehicle. On the next one, it's going to be 1200 newtons forward for the FT2. Here FT2 is backwards 1200 newtons. And my overall force is 1500. So basically that's it. There you have this type of tension question. So again, what you're trying to determine are these values. They should always be equal because these are third law action-reaction pairs here and here. And tension is always the same between the objects. It's always acting outwards. So that's it. Hopefully you learned something from this video too. Take care. I'm going to read